Another concept related to environment. With reference to marine biogeochemical process, consider the following statements regarding the biological carbon pump and ocean acidification. Okay, so what is this biological carbon pump? First of all, biological carbon pump. This mechanism happens in the ocean environment. So we know atmosphere has carbon dioxide, CO2 is there, and on the ocean surface the carbon dioxide can dissolve into the oceanic water, and from oceanic water also carbon dioxide can be a small portion can be released back into the atmosphere. So here first of all photosynthesis is happening. The photic zone in the surface region, photosynthetic organisms are there. We know the phytoplanktons, they by photosynthesis takes up carbon dioxide and convert them into organic compounds. Photosynthesis is the process by which carbon dioxide is absorbed and fixed as organic compounds. Okay, the carbon. Okay, so photosynthesis. So phytoplanktons will be there, and the phytoplanktons will be fed by the fishes or zooplanktons. Phytoplanktons are there. Zooplanktons will be consuming that, and zooplanktons will be consumed by other organisms also. So all these organisms, they excrete, they also die. Though say the shell forming organisms, calcium carbonate is the shell. Here also one carbon get fixed. In the carbonate, one carbon get fixed. In all other organic compounds also, the carbon is getting fixed. So these organisms, shells, zooplanktons, fishes, phytoplanktons, they may excrete or they may die. So what they will do, all the excreta and dead particles, they form small clumps, aggregates. They form aggregates and they start to sink. They start to sink. The sinking organic compounds, including calcium carbonates and other forms of carbons, the sinking are known as marine snow. So how in the atmosphere snowing happen, very similar manner, the carbon is sinking into the deeper region, that is known as marine snow. Okay, at the deeper level, what will happen? Some of these carbon will be decomposed. Decomposition happens. Some of the organic material that is sinking, that get decomposed. Whenever decomposition happens, the carbon dioxide will be released again. And this carbon dioxide will again be mixed in the surface water, and that can be exchanged back also. Okay, exchanged back, or it can be used again for the photosynthesis purpose also. Okay, so some portion alone is exchanged. The remaining portion goes deeper. The carbon, organic carbon, that is crossing the depth of 100 meters. Okay, that gets stored for hundreds of years together in the bottom of the ocean. Okay, that we call it as the amount of carbon which is crossing the 100-meter depth level. Okay, 100 meter is the below which there is no light. Okay, so which is crossing here, this we call it as carbon flux. Okay, they get permanently stored in the bottom of the ocean. They go and settle in the bottom. They go and settle in the organic carbon. They go and settle in the bottom. So it remains there. So sometimes the upwelling current can bring it back. The upwelling current from the deep of the ocean, an upwelling current can happen. Okay, so the upwelling current can bring these carbon above, and again the carbon can be decomposed and it can be again sent back into the atmosphere. Otherwise, the deeper carbon gets stored in the bottom of the ocean itself for years together. And carbon means organic material, the tissue material and all. Okay, they get settled on the bottom of the ocean for years together, and slowly they can also become sedimentary rock. Geological fixation. It can be in the bottom as a sediment also, and that can become rock also. That is sedimentary rocks, and that is known as geological fixation also. So that get fixed in the oceanic bottom for longer duration. So this is, and when this has an opportunity to come back means upwelling current can bring this back, and it can release it back into the atmosphere. So usually the upwelling current, when it brings the organic carbon which is stored in the bottom of the ocean, the amount of carbon dioxide released to the atmosphere will be more. Yes, we all have learnt that whenever the upwelling current comes, here some phytoplanktons grow feeding on the nutrient material. The amount of carbon dioxide absorbed by the phytoplanktons is less, but the amount of carbon dioxide that is given to the atmosphere is more. So naturally upwelling regions are releasing, degassing carbon dioxide into the atmosphere. From the ocean, carbon dioxide is released to the atmosphere. So that is also there. And another concept is also questioned in the particular question, that is regarding the acidification. Whenever acidification happens, the carbon dioxide mixing with the water get acidified. So H plus ions are more, and this H plus ions will consume the carbonate ions. CO3 ions also will be consumed. So more and more CO3 ions will be, HCO3 ions will be consumed. So then the carbonate will not be there available for the marine organisms to form the shells. Only if the shells are formed, the shells can go down and get fixed as a sedimentary rock or in the bottom of the ocean. So the biological carbon pump get affected by acidification of the ocean. That is in nutshell. Okay. So yes, what is biological carbon pump? The atmospheric carbon get fixed into oceanic carbon in the photosynthesis, and it slowly sinks down. That is known as marine snow. Once it crosses 100-meter depth, it is known as carbon flux. Okay, it goes down and it gets stored for hundreds of years in the ocean bottom. Only thing that can bring the ocean bottom carbon back to the surface is upwelling current. Upwelling current usually bring the carbon from the bottom of the ocean and degas it, release it back into the atmosphere. Okay, more into the atmosphere. And acidification can affect the amount of carbonate that is formed. The shell formation can be affected, and it can reduce the effectiveness with which the biological carbon pump can operate and store the carbon for longer years. This is the understanding regarding the biological carbon pump. Okay, so you can see here from atmosphere, phytoplankton capture carbon. So phytoplanktons will be fed by the zooplanktons. So when they die, when they excrete, they combine, they form, and they start to sink. Okay, and they start to sink. Here some decomposition, some level of decomposition can be there, and the decomposed carbon dioxide can come up and it can go to the atmosphere back. So those carbon which escape the decomposition and then go deeper, that gets stored for hundreds of years in the ocean bottom. From there, only the upwelling currents can bring back the carbon and release it to the atmosphere. Now with this knowledge, we will go through this question. The biological pump transfer carbon from euphotic surface layer, yes, ocean surface layer, to the deep ocean primarily through the sinking of particulate organic carbon, marine snow, and calcium carbonate shells. Right. This is right. Ocean acidification decreases the ocean's pH by increasing the concentration of hydrogen ions, which reduces the saturation state of carbonate ions, making it making calcification hard organisms like coral and pteropods. So this will be affected. Carbon getting stored in the bottom of the ocean as carbonate shell will get affected. So the statement is right. Upwelling zones act strictly as atmospheric carbon sinks because high nutrient availability triggers phytoplankton's bloom that immediately absorbs more carbon dioxide than the upwelled water releases. This is wrong. uh, this happens, but quantitatively, if you compare, the amount of carbon that is released into the atmosphere is more than the amount of carbon that is getting absorbed from the atmosphere. So this is conceptually wrong. This happens. Okay, the phytoplanktons grow, they bloom, all those things they absorb, but more alone is wrong. They absorb, but they absorb less carbon dioxide compared to the upwelling water releases to the atmosphere. So net, there is the carbon dioxide released to the atmosphere is more compared to the carbon dioxide absorbed by phytoplankton. So this alone is wrong. A difficult question. B is the right answer.